Okay, we had types of magnets, natural, artificial, and artificial can be broken up into temporary and permanent. These are just definitions. And then magnetic field, we talked about how every magnet is surrounded by a region where magnetic field is present, right? And the magnetic field at the poles was where it was concentrated the most, right? Everybody sees 1, 2, 3, 4, 5 lines going this way, just as representation of magnetic flux. 1, 2, 3, 4, 5 lines coming this way, but at the poles, all 10 lines are going in. Okay, so at the poles is where there's the most lines of flux. Points where the magnetic lines of force leave and return to the magnet. They leave out of the North Pole, enter the South Pole. Like poles attract, and unlike poles repel. Like poles attract, unlike poles. Oh, sorry, like poles repel, unlike attract. Lines of force, know the definition lines of force, or what magnetic flux is. And magnetic flux are lines of force. Know the characteristics. Magnetic lines of force are not tangible, form closed loops, never cross, repel each other, lines of force tend to shorten. Okay, and this is the example that I use with the soft iron. Okay, if you put a piece of iron or something else that is permeable, you bring it near a magnet, you'll feel that force, right? Those lines of flux are widening, going to whatever it is, that piece of material that you're bringing in close proximity to the magnet. As soon as you remove it, those lines of flux collapse. Okay, you don't have to memorize how many lines of force equals 1 Weber. Okay, flux density. This is in your formula sheet, yes? Okay. It's the lines of force measured in Webers divided by the cross-sectional area measured in meters squared. Okay, and this is measured in Teslas, and the symbol is beta. Okay, magnetic induction. This was just some background information on magnetism. This is an external magnet. We talked about the screwdriver. This is where I gave the screwdriver example. If you put a magnet up to a screwdriver and you leave it there for a good amount of time, after a while that screwdriver tip is going to become magnetized, right? You pick up little screws with it. After a while, all these magnetic domains will go back to their original, or to some other state other than being aligned like they were when we left the magnet on for a while. Okay, so that's what we're talking about, magnetic induction. Retentivity is the ability of materials, is an ability of a material to retain its magnetism. Permeability is the measure of how easily something is magnetized. Permeability of free space is a fixed value. I don't think this is on your formula sheet, is it? Is this value, no, 4 pi, okay, probably for good reason. Relative permeability is just permeability of the material, whatever it is that we want to find permeability of, over the permeability of free space, which is a fixed value. Okay, reluctance. This is to magnetism what resistance is to electrons. All right, left-hand rule. Know the definition, left-hand rule. No electromagnetism. And the left-hand rule for coils. Know the 3 left-hand rules: conductors, coils, and generators. Okay. You may ask something, the thumb points to what? First finger points to what? Okay. Magnetomotive force, the force used to set up the magnetic to set up the magnetic flux. MMF equals number of turns times the current. And it's measured in volt amps. All right, that was lesson 1.